Okay, we are moving on to chapter 5 today. Lesson 5.4 is solving compound inequalities. We're going to learn how to set up inequalities when the word and is involved. We're also going to learn to set up inequalities when the word or is involved. They're very tiny words, but they make a big difference in the way you set them up. So we're going to start off with this example. X is greater than 2 and x is less than 5. So if we graph that on our number line here, what kind of symbol goes at 2? An open circle at 2. And we also have what circle at 5?
Open.
An open circle at 5. So if x is greater than 2, which way do we shade?
Right.
To the right from 2. And x is less than 5, which way do we shade from 5? Left. So what we have here,
It should be 3
well, it could be any number greater than 2 and less than 5. And so it could be a decimal or fraction, right?
Yeah.
Okay, so this is called an intersection, because if you think about, if we graphed each of these individually, you would have one graph that goes this direction and goes forever greater than 2. And if you had another one, you'd have this one that graphs at 5 and it goes this way forever less than 5, right? But that place where they meet is called an intersection of those two graphs. And so when you have the word and, you have an intersection of the two graphs. And the way we would write this, by the way, we would write it 2 is greater than x, and x is less than 5. Okay? Could be. We also could write it as a solution in a set builder notation that would look like this: the set of all x such that 2 is greater than x and x is less than 5.
Do we have to do that though, or can we do that one?
You're going to need to know how to recognize it because you're going to see it in today's lesson.
Okay.
Tessa.
Why did the sign get flipped on to an X?
Well, because it's this same thing, isn't it? That's the same thing. 2 is greater than x is the same thing. No. I wrote it backwards. Thank you. I wrote it backwards.
You put the X in.
Thank you very much for correcting me. So 2 is less than x. See how confusing it can be? 2 is less than x and x is less than 5. Thank you for catching that. All right. Did that just totally ruin it for everybody now? You're totally lost, right? Sorry about that. So 2 is less than x and x is less than 5 is the way that we would write it. Might have gotten ahead of myself there a little bit. All right, so now we just have some examples to look at. Solve and graph the intersection of this guy right here. And what's different about this one?
There's
Is there an equal sign and there's a regular sign?
Well, there's one that has an equal sign and one that has a regular sign. What else is different about it?
there's numbers.
Yeah, it's not just x in the middle. Now we have actually two different inequalities to solve.
Do we have 3 to both sides?
So we need to do two different inequalities. -2 is less than or equal to x minus 3. And so we would solve this. So 1 is less than or equal to x. We also need to do this part, which would be x minus 3 is less than 4. Add 3 to both sides. So x is less than 7. Okay? And we would make a number line. Number lines get a little bit more complex with these type of inequalities. And so you have 0 here, 1, 2, 3, 4, 5, 6, 7. So I need what symbol at 1?
Closed.
We need a closed circle at 1.
Open.
And we need an open circle at 0, or at 7, right? An open circle at 7. So x is less than 7 means we shade this direction, right?
Mm-hmm.
And x is greater than or equal to 1 means we share this direction. And so we can see that the graph has an intersection here in the middle, right? So everything in here needs to be shaded.
Yeah.
All right. Does that make sense? And if we were to write it in set builder notation, set of all x such that 1 is less than or equal to x, and x is less than 7. Oops, close my brackets. All right. Solve and graph the intersection. Y minus 3 is greater than or equal to 11, and y minus 3 is less than or equal to negative 8. So add 3 to both sides. Y is greater than or equal to 14. Add 3 to both sides here. Y is less than or equal to negative 5. Negative 8 plus 3, huh?
It just goes two different ways. They wouldn't like connect.
There's no intersection.
They wouldn't.
Oh.
Maybe I wrote the
Yeah, why would it have to be two
maybe
different
I
numbers?
might have turned it around. Let me check my resources here.
Why would it have to be two different numbers?
I could have made a mistake. It wouldn't be the first time. Oh, that was supposed to be a negative 11. That's what I did wrong.
Nasty.
Sorry. That's supposed to be negative. So negative 11 plus 3 would be negative 8, right? Okay. So y is greater than negative 8 and y is less than negative 5. So negative 8, negative 6, negative, what? Negative 6. Man, I'm struggling. I am struggling. Sorry, guys. Stinks that it's a Monday.
Oh, you
Oh, wait a minute.
It's
It's
Friday.
Friday.
You
Okay.
actually got me there. I was like, oh.
All right. So a closed circle at negative 8 and a closed circle at negative 5, and we shade in between. That's going to be a different one here in a minute. All right, we're going to get to that. It's going to be an or. All right. So, and of course, set builder notation, set of all y such that negative 8 is less than or equal to y, and y is less than or equal to negative 5. All right, last one. Okay, so is it confusing if I do a -7 here
Then do two minus.
and do a -7 here and a -7 here? Does that
No.
confuse anybody?
Oh, no.
All right, I hope not,
No,
because
you're
it's
good.
it's okay because we're just treating these as we're still treating these as two different inequalities, and we could write it out this way. So -1 is less than or equal to r, which is less than or equal to less than 3. Okay, so now we can go ahead and graph it. -1, 0, 1, 2, 3. I'm okay if you have if there's a really big spread of numbers. By the way, you don't have to put all of them on the. You can count by 5s or 10s or something if you need to on your number lines. They don't have to be crazy. -1 gets a closed circle, and 3 gets an open circle. And since it's an and, we shade in between. And we would put it in set builder notation. set of all numbers R such that -1 is less than or equal to R is less than 3. Okay. Not too bad, right?
No, it's not bad. I like it.
Next, we've got or statements. So x is less than or equal to -1 would look like this, and shade to the left, correct?
Uh-huh.
Or x is greater than 2, so an open circle at 2, and x is greater, so it shades to the right.
Yeah.
Okay?
That's just cool. You're done.
But how would you write that in set notation?
How would you write that in set builder notation? That's a great question. You gotta,
Good job, Ryan.
it's gonna write, you're just gonna write it just like it says. So we would write it in set builder notation this way: the set of all x such that, such that x is less than or equal to -1, or x is greater than 2. Greater than r, what? Greater than 2.
Close it, close it.
And close the symbols, thank you.
Yep.
Alright. Solve and graph the union, and when we have, I forgot to say, when we have two graphs, when we have an or statement graphed on the same number line, it's called a union of the two graphs. So we're joining together two different graphs that go different directions. Okay, so the graphs don't intersect, but they're still united on the number line. Solve and graph the union. We've got two different statements here, so subtract 1 here. A is less than 3, or add 1. A is greater than or equal to 4. All right? And so we've got, this one doesn't require much, 2, 3, 4, 5. So a open circle at 3, A is less than 3, so it goes that way, and a closed circle at 4, and A, or A is greater than 4, so it goes that way. So basically, A can't be anything between 3 and 4. So set builder notation, set of all A such that A is less than 3, or A is greater than or equal to 4. 8.
You said enough score would be 3 is greater than A and A is greater than 4.
Oops. Like this, A is greater than or equal to 4.
Yeah.
I think that'd be okay. I don't know why they don't write any of them that way in the book, but
Wait, wouldn't that be,
3 is,
no, because it's or, and they're going to be correct. Is that
but it still says, I mean, A is less than 3 can be written as 3 is greater than A. Those are the same thing. And then this one still stays the same direction. A is greater than or equal to 4. I think that'd be okay.
Yeah. Working with it.
I'm gonna say it's okay for
Well,
now
that would
if it's,
mean 3 would be greater than 4,
Listen to the back.
if you said that.
And then 3.
Because it would also imply that.
no, 3 is greater than A, so A has to be less.
I know, but if A is greater than 3, that would mean A would have to be,
But A is not greater than 3.
I mean, A is less than 3, that means A would have to be less than 4.
If A is less than 3, oh,
Yeah.
okay, I see what you're saying. So this really doesn't work because
Yeah.
what we really need is two statements. Because it can't be both, this would, the way we had it there would mean that both could be true and they can't both be true. It's gotta be one or the other. Okay, so I see what you're saying. I like this better then, for that reason. The or needs to come in between those to eliminate the possibility of of two things being true that can't both be true. Okay?
Do you have to capitalize for?
No, I don't think you have to. I do it because my handwriting's sloppy and it's maybe easier to read if I capitalize stuff sometimes. All right. X is less than or equal to 9. Well, that one's pretty simple. We don't have to do anything there. Or 2 plus 4x is less than 10. Subtract 2. So that would be 4x is less than 8. Or x, sorry. Divide by 4. X is less than 2. All right. It's a long number line. 2. Put a 5 here, and a 9 would go about right there, right? Okay, so we need an open circle at 2, and x is less. And we need a closed circle at 9.
Left.
X is less than or equal to 9. Huh.
So it's not
What do you think about that one?
it's a.
It still works.
It still works. And what we figured out here is this: the overall.
So couldn't X be anything under 9?
There you go. That's what it amounts to. So our solution set for this one ends up being the solution of the set of all numbers x such that x is
Less than 9.
less than or equal to 9. Because this is included in that, right?
Yeah.
Okay. Everything that's true about this one is also true about this one. So it ends up being just one solution. And that happens sometimes. And that's okay. All right? Heidi?
But if you put 2 in there accidentally, like not knowing that, would it still be right, or would you have to put that?
You need to be able to recognize that the x is less than 2 is included in this one. And so this is the simplest way we could write the answer. Okay? Hey,
Wouldn't that mean that anything in between 9 and 2 wouldn't be that because X has to be less than 2?
no, because any solution that I choose that works for both of it has to fulfill one or the other. And anything that fulfills this one automatically fulfills this one. Okay? Or no, I said that backwards. Anything that fulfills this one automatically fulfills this one. And so the or statement is met by either one of those. Any or statement that works for this one is automatically going to work for this one, so we just can leave it out. All right, so next, got to work a couple more examples here. Solve and graph the union of this one. Notice we've got a negative that we're going to have to deal with here, so what do we have to do when we have negatives? Flip the sign, so don't lose track of that. Subtract 7, so negative 2m is less than or equal to 6. Divide negative 2, so m is greater than or equal to negative 3. Subtract 12. 5m is greater than 25. Divide 5. So m is greater than 5. All right? So m is, let's see, negative 3. Here would be 0, and here would be 5. So what symbol goes at negative 3? Closed circle, and which way?
To the right.
To the right. And then what symbol at 5? Open, and it shades to the right once again. So, so our solution set ends up being for this one, the set of all m such that m is greater than or equal to -3.
Yes.
Okay, we don't have to include the other one because anything that works for this one automatically works for that one. Okay. All right, last couple here. We just got to be able to set these up using some word problems. 8 less than a number. So 8 less than a number. That would be -8. Than means x goes in front of it. Is no more than,
So
less than or equal to 14. And no less than 5. So greater than or equal to. And no less than means greater than or equal to. Greater than or equal to 5. All right. So x minus 8 is no more than 14. And x minus 8 is no less than 5. Okay, so add 8. X is less than or equal to, is that 22? Add 8 to both sides here, so x is greater than or equal to 13. So if we have a 13 here, have like 15, 20, and then 22 here. So x is greater than or equal to 13 would be this. And x is less than or equal to 22 would be this. So we've got an intersection of the two graphs, right?
Yes, it's an and.
So it's an and. X, set of all numbers x such that x is, or such that, sorry, we've got to start with 13 is less than or equal to x, and x is less than or equal to 22. The product of -5 and a number, so -5x is greater than 35 or less than 10. So -5x is greater than 35 or -5x is less than 10. So divide by -5. X is less than -7. Divide this one by -5. And x is greater than -2. -7, -5, -2. So x, open circle, x is less than -7. Or x is greater than -2. Solution set would look like set of all x such that x is less than -7 or x is greater than -2. All right, that was kind of a lot of examples we worked through. Keep this out while you're working on your worksheet today. The examples maybe will help you out a little bit.